The sky above our early ancestors poses a deep enigma. Planets close to the Earth. Electrical discharge formations between planets. And as we'll show in this episode, the extraordinary forms taken by the cosmic thunderbolt. How do we deal with the glaring contradiction between things taken for granted in the sciences today and our own reconstruction of planetary formations and high-energy electrical events in the ancient sky? Throughout the 20th century, it seems that textbook astronomy staked everything on a universe driven by gravity alone. No interest in electrical phenomena. But then came the great surprises of the space age. In every direction we look, we see a tapestry of high-energy events, magnetic fields, and fine filamentary structure, all pointing to pervasive electric currents. And make no mistake about it, the magnetic universe is now acknowledged by astronomers. Only electricity can create magnetic fields. Only electricity can sustain magnetic fields in the vacuum of space. In our own investigation, a critical turn came in late 1996. That was when the Australian physicist Wallace Thornhill convinced me that planetary formations I'd reconstructed from ancient testimony alone were fundamentally electrical. The gathered planets were the anodes and the cathodes, the positively and negatively charged bodies in electric discharge formations. I could then see that not just ancient events challenge popular theories today. Discovery by discovery, one surprise at a time, the space age is moving all of science closer to an understanding of the electric universe. The universe is an ocean of charged particles, plasma, where the raw electric force can be incomparably more powerful than gravity. From this perspective, there's no better news than the new telescopes detecting events across the entire electromagnetic spectrum. As we've seen beyond visible light alone, the universe has come alive with electromagnetic activity, from infrared and radio waves at the lower end of the spectrum to X-rays and gamma rays at the higher end. When radio telescopes began to peer into the core of the Milky Way, astronomers were stunned by its high-energy arcs, threads, and filaments. Then radio telescopes began to reveal galaxies immersed in high-energy electromagnetic activity. How does this surrounding activity affect the evolving structure of the seemingly tiny galaxy held in its grasp? In every direction we look, we see a tapestry of high-energy events, magnetic fields, and fine filamentary structure, all pointing to pervasive electric currents. It is electric currents across immense distances that will explain what gravity alone could never explain. Here was the best view of the galaxy M87 in 1990, but once we began to see inside the galactic glow, the view exposed an axial jet spanning thousands of light years, which means thousands of trillions of miles. What has excited these rarefied particles and accelerated them to stupendous energy levels while holding the particles in a narrow jet across unfathomable distances? The energies are so high that the electromagnetic emissions include something called synchrotron radiation, the most energetic form of radiation known to science. Synchrotron radiation was discovered first in the laboratory by engineers working with particle accelerators to accelerate electrons to nearly the speed of light, while using intense magnetic fields to force these charged particles into a spiraling motion. The effect of such motion is radiation across the entire electromagnetic spectrum. Synchrotron radiation in space means an electric universe. Closer to home in our own galaxy, new telescopes have exposed spectacular nebulas and stellar displays exhibiting all of the extreme energies and fine structures expected of electric discharge in space plasma. Towering plasma columns, bipolar discharge, plasma toruses, radial discharge, and giant wheels turning on axial jets in space. This was the view of the Crab Nebula in the 1980s. Then, with Hubble and its many complements, an explosion of energetic detail greeted astronomers, and at its core a churning engine familiar only to electrical engineers, emitting everything from X-rays to radio waves, a confirmation of synchrotron radiation. Yes, the picture of space has changed, but follow the trail of surprises. Observe how astronomers struggled with things they weren't trained to recognize. But most were well trained as mathematicians, of course. So when gravity began to fail them, abstract mathematical solutions were their first recourse. Black holes, dark matter, dark energy, neutron stars. A good illustration of the point is the now famous graph in which normal matter is only 4% of the mathematician's universe. The remaining 96%, dark matter and dark energy, is invisible at any and all wavelengths, outside the reach of mortals, but elegantly preserving the sovereignty of gravity. Whatever you may think of these concepts scientifically, within the culture of science, as a matter of historical record, they became cover stories for the failure of gravitational theory. It seems that astronomers paid too little attention to the pioneers in the study of electricity and charged particle behavior. Experimental work by Nikola Tesla, the first to demonstrate alternating current, changed the world. But astronomers didn't hear his warning. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. The Norwegian experimentalist Christian Birkeland was the first to identify charged particles from the sun as the cause of the auroras. He wrote, "It seems to be a natural consequence of our points of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds." And Nobel laureate Hannes Alfvén, the acknowledged father of plasma science, became a towering critic of directions in mathematical astronomy. Students using astrophysical textbooks remain essentially ignorant of even the existence of plasma concepts, despite the fact that some of them have been known for half a century. Particularly noteworthy today is the work of Alfvén's close colleague, plasma scientist Anthony Peratt. It was Peratt's supercomputer simulation that showed how twin currents, now called Birkeland currents, interact to form spiral galaxies, no dark matter needed. Also, we'll take up Peratt's most recent work, a massive scientific investigation of rock art the world over, all confirming high-energy plasma configurations in the sky. Our goal is to understand celestial events once remembered around the world, and this will require an interdisciplinary approach. We'll respect all data returned by space probes and new telescopes. We'll respect more than a century of groundbreaking research on electricity in space. And we'll respect the archetypes, the global patterns of cultural memory in ancient times. It will be the convergence of evidence that throws a new light on our own past. And amongst the best witnesses will be our planetary neighbors, Their surfaces will speak volumes for electrical events and cosmic upheaval in the not-so-distant past.